Hello. This video is going to show how we can measure structural coverage using the LDRA tool suite and also the ARM Development Studio. Now, inside ARM Development Studio, I've opened one of the example projects that ARM provide, and this is this fireworks example for Cortex A9 running on the simulator and using the ARM compiler 6. And as you can see, it uses this graphical interface, and I want to find out, as this program executes, how much coverage do we actually obtain. So this is the ARM Development Studio, and this is version 2020.0. And here we can see I've got this fireworks example project for the ARM compiler 6. So first of all, let's go and build this. So we'll go and do a clean, and then we'll do a build. And we'll check this build. So there we can see it's using the ARM compiler 6, and we now have this executable. So let's go and run this. So I'm simply going to go and connect to the target. Okay, that's opened up the simulator. This is now running. So I'm going to go and execute it. And we should find that we have the graphical interface. And there we can see we have our example that's running. So this is going to run for a while, and what I need to do in order to get coverage is at some point I'm going to have to say, well, stop, let's get coverage off the target. And what I'm going to go and try and find is the point where the banner actually gets to the end of the screen, and that will be a good point to say, stop, let's upload the execution history. So at this point I'm going to stop this, and we'll close this down, and I'll stop that. Okay, and if I take a look at the code for fireworks, I can see there's a function called move banner, and inside this function I can see that if this variable gets to the screen width, then it resets it to the start. So that would be a good point here to actually insert a command to say stop, let's upload the execution history. Right, now let's switch to TB Vision. So this is TB Vision, and what I've done is I've analyzed the source code inside that project. And what I'm now going to do is I'm going to go and instrument the source code, and then I've already instrumented it. I'm going to build it, then I'm going to execute it and perform the dynamic analysis. Now, in order to get the program to stop, I'm going to have to modify something in order to say stop, let's upload the execution history. And the simplest way to do that is to actually find the instrumented code. So here I found the function move banner, and at this point I can see that if banner x equals 800, then it's going to reset it. And so what I've done is I've inserted this call to upload execution history inside the instrumented code. You may be wondering what these are. Well, these are effectively the probes that we put into the code, and as we can see, each probe, all it's doing is simply setting one bit inside a structure, so that's very efficient. Okay, so let's go and perform the build, and then we'll execute it, and we'll be able to perform the dynamic analysis. So this is now performing the build. So it switched the normal code with the instrumented code in order to be able to use the same build mechanism. I'm now using the same launch configuration that we used earlier on. This is now going to start executing, and we should see that it's going to download. Okay, started the simulator, and there we can see this is now running exactly the same as it did before. And as we can see, the performance is very, very similar. Our probes are really not impacting the performance at all. And all it's doing is simply setting these bits each time the probe gets hit. And it's not until the plane is actually, or the banner is going to come off the screen, that then that function upload execution will be hit, and that will then transfer the data back from the simulator or from the target back to the host, and will then analyze it. And there we can see we've extracted the data from the target. We're now analyzing that data, and we're going to be able to find out, well, how much of that code have we actually exercised. So just need to wait for it to finish analyzing these history files, and then we'll take a look at a test manager report, and we'll be able to find out what coverage we've obtained. Okay, so it's just generating the final reports, And now we should be able to go and generate a test manager report. And inside the test manager report, we're going to have information about the code review, the quality review, but more importantly, what I'm interested in is the dynamic analysis. So code review, quality review, and here we've got the coverage. And as we can see, we've got pretty reasonable coverage. For the fireworks.c, we've got 98% statement coverage, 86% branch coverage, 67% MCDC. Let's go into that and take a closer look. So the code is not under version control, but if it was, we'd be able to show what version of file we've analyzed. We've had one run, and if we scroll down here, we can see the coverage is not too bad. If we go into plot pixels, then we can see line by line, and we can see we've got a couple of lines here that we've not executed. Why haven't we executed that? Well, it looks like the height has never been less than 0. And similarly, we've got width, that's never been less than 0. This is typical defensive coding, and of course, that's not been executed. If I wanted to get coverage from that, then I could effectively do some unit testing in order to obtain that. Okay, so if you'd like more information, then please don't hesitate to contact us at LDRA. Thank you.